Hello students, so now let's start with problem number 4 on nth derivative of algebraic function. So guys, here we have a function for which we are going to find out the nth derivative by using the formula of successive differentiation. So now here we have value of y as x into log of x minus 1 upon x plus 1, and we have to prove that given result. Now guys, if you see the function, then it's a combination of logarithmic and algebraic function. So to get the nth derivative, that is y of this given function, we don't have any standard formula. So guys, what I'll do is, to find out the nth derivative, as we have seen in the theorem or the proof which I have covered in the previous videos, that whenever you want to find out nth derivative, we always find out first derivative, second derivative, third derivative, and then we predict what could be the nth derivative. So similar approach I will use over here. So since I don't have the standard formula to find out nth derivative of x into log of x minus 1 upon x plus 1, I will find out the first derivative and then we'll see what could be the nth derivative. So let's start. So guys, here the y I will rewrite as x into log of x minus 1 minus log of x plus 1. So this is the property of log, that is log a upon b is log a minus log b. Now guys, here what I'll do is I will use the derivative rule, that is the u into v rule, or which is also called as product rule. So by using product rule, we'll find out the value of y1. So y1 is nothing but the first derivative of this y. So accordingly, let's assume this x as u and this term as v. So we say it is u into derivative of v. So derivative of this part is 1 upon x minus 1 minus 1 upon x plus 1 plus v will remain as it is, and then derivative of u. So log of x minus 1 minus log of x plus 1 as it is, and the derivative of x is 1. So guys, this is the value of y1. So if we rearrange this, then we'll get x upon x minus 1 by multiplying this bracket with x, minus x upon x plus 1 plus log of x minus 1 minus log of x plus 1. Now guys, if you observe last two terms, then for these two terms we can definitely find out the nth derivative, because we have standard formula for these two functions. But if you observe first two functions, then finding nth derivative is not possible, because if I compare it with these two formulae which are for the algebraic function, then in the numerator we should have 1. Now guys, here we have x in the numerator. So what we'll do is, here we'll add 1 and subtract 1, so that we'll get 1 in the numerator, and then we can convert it in the formula number 1 or 2, and then we can get the answer of nth derivative. So guys, for that, here I'll subtract 1 and I'll add 1. So if I subtract 1 from here, then we'll get here yn as x minus 1 then plus 1. So here I am subtracting and adding 1. I'll divide separately by x minus 1. So here we'll get x minus 1 and here we'll get x minus 1. Next, we have minus sign here. So I'll keep that minus sign as it is. Now in that x, I will add 1 and then I'll subtract 1 and will divide it by x plus 1 separately. I'll keep it inside the bracket. Next, last two terms as it is, that is now guys, here x minus 1 cancelled, here we'll get 1. Here it is cancelled, we'll get 1, but due to the minus sign that will become minus 1. So 1 and minus 1 will be cancelled. So we'll write the remaining terms. So we will get 1 upon x minus 1 from here From here we'll get minus minus plus 1 upon x plus 1. And last two terms as it is. Now guys, we got four different terms, and these four different functions are given or are in a form where we can definitely find out the nth derivative. So guys, here I am writing y, but it is y1. So let me change it. It is y1 because we got y1 on the previous page. So guys, now y1 is given in such a form that now we can easily find out the nth derivative of this each and every function. So let's start. So for 1 upon x minus 1 and 1 upon x plus 1, I'm gonna use this second formula, that is 1 upon ax plus b, and for this log x minus 1 log x plus 1, I'm gonna use the third formula. But guys, before applying the formula, you have to observe the function again. So this is the answer or value of nth derivative if your y is 1 upon x plus b. But guys, if you observe here, then here we have a value of y1 and not of y. So you must be thinking what will happen in this case. So let me explain you. So guys, understand whatever I'm explaining you now, because that is gonna decide how that nth derivative is gonna change. So guys, let's take an example that I have a function y which is, let's say, x to the power 5. If I ask you what is value of y1, you will say 5x raised to 4. If I ask you y2, it is 20x cube. y3, it is 60x square, and so on. Now let's take another case in which I say value of y1 is x to the power 5. So if I ask you the second derivative, it will be 5x to the power 4. The third derivative would be 20x cube, and the fourth derivative would be 60x square. Now guys, just observe a small difference, that whenever we started y as x raised to 5, we got value of y3 as 60x square. But when I said that x raised to 5 is my y1, my y3 got shifted by 1, that is y4. So remember, whenever your function get shifted by one or two orders, its derivative also gets shifted by those many orders. So when you start something at y, let's say you are getting value of yn, and let's say if same function is starting at y1, then your yn will be shifted to yn plus 1. Or let's say if your y is shifting to y2, your nth derivative will shift to yn plus 2. So same thing I want to explain you over here. So here what happened guys, the value of 1 upon x minus 1 is given at a step y1. So for y1, if I find out the nth derivative, I will get yn plus 1, because that nth derivative will also get shifted by 1. But guys, I want yn in the answer. So for that you have to observe the question. So in the question, it is given that we have to prove that yn is equal to this. It means I want answer of yn and not of yn plus 1. So let's take one scenario. So right now, as we are saying, the value of y1 is 1 upon x minus 1. So if I use this formula to find out the nth derivative, I will get y of n plus 1 as here minus 1 raised to n into n factorial upon x minus 1 raised to n plus 1. So guys, the nth derivative has shifted to n plus 1 derivative. Now in the answer I want yn. So what we'll do is, since I want yn, from yn plus 1, we will reduce each and every n by 1, so that we can come from n plus 1 step to n. So here we will get minus 1 raised to n minus 1. Here we'll get n minus 1 factorial. Here we'll get x minus 1 raised to n, because we are reducing each and every value of n by 1. So that will become n minus 1 plus 1, that is n. So guys, it means For y1, my yn will be minus 1 raised to n minus 1 n minus 1 factorial upon x minus 1 raised to n. So this value of yn, I'm gonna use it over here. So guys, here I'll say the value of yn is equal to here minus 1 raised to n minus 1 into n minus 1 factorial upon x minus 1 raised to n. Similarly, same concept I'll apply for the second function because that too is algebraic function. So I'll get plus minus 1 to the power n minus 1 n minus 1 factorial upon x plus 1 to the power n. Now guys, let's move to the log of x minus 1 and log of x plus 1. Now, according to this formula, if value of y is log of ax plus b, this is the value of yn. But guys, here I have log at a step y1. So it means I'll get this answer at yn plus 1. So what I want yn in the answer. So I will reduce each and every power by 1. So here I'll get n minus 2. So here I'll write plus minus 1 to the power n minus 2. Here we'll get n minus 2 factorial. So n minus 2 factorial upon, now value of a is 1 because ax, here we have 1x. So a is 1. 1 raised to n is 1. Here we'll get x minus 1 and this power will also get reduced by 1. So here we'll get n minus 1. Same thing we'll do with the last term. So minus 1 to the power n minus 2 n minus 2 factorial upon x plus 1 to the power n minus 1. So guys, it is 1. So this is what the nth derivative of these 4 functions. So here we get y, but that is not the requirement. So if you observe the question, we have to prove that the answer is this. So let's try to find out the value of y. So guys, now what we'll do is, to get that answer, we will take few terms common. So from these 4 terms, if you observe, we have minus 1 raised to n minus 1 and minus 1 raised to n minus 2 term. Now out of these 4 terms, if you check, then the lowest term or the minimum term is minus 1 raised to n minus 2, because guys, in minus 1 raised to n minus 1 and minus 1 raised to n minus 2, minus 1 raised to n minus 2 is smallest. So we'll take that minus 1 raised to n minus 2 common. So let's see what we get here. So here I'll say yn is minus 1 raised to n minus 2. Next, we have n minus 1 factorial and n minus 2 factorial. Now out of n minus 1 factorial and n minus 2 factorial, n minus 2 factorial is the lowest. So here I'll say, let's take this n minus 2 factorial outside. Now from denominator we can't take anything common because all terms are different. And let's write down remaining terms in the bracket. So from first term we'll get, let's see what we get. So here we had minus 1 raised to n minus 1. We have taken minus 1 raised to n minus 2 outside. So here we will get minus 1 raised to 1. So guys, you always have to cross check. So if I multiply these 2 terms, I'll get minus 1 raised to n minus 2 plus 1. Now n minus 2 plus 1 is n minus 1. So that's correct. Next we have n minus 1 factorial. Now guys, what is n minus 1 factorial? So let me show you that. So here I'll show you. N minus 1 factorial is n minus 1 into n minus 2 factorial. So we generally reduce the term by 1 while finding the factorial. Out of that we have taken n minus 2 factorial common. So only n minus 1 will remain in the bracket. So here I'll say it is n minus 1 upon denominator as it is, that is x minus 1 raised to n. Next, from the second term, again it is similar. So we'll get similar numerator. So here I'll say it is plus minus 1 raised to 1 and n minus 1 upon Here we'll get x plus 1 raised to n as it is. Now, from the third term, minus 1 raised to n minus 2, n minus 2 factorial, both are outside. So we'll get only 1 in the numerator upon denominator as it is, which is x minus 1 raised to n minus 1. And then the last term, negative sign. So minus 1 upon x plus 1 raised to n minus 1. So guys, we got these two terms outside. Now again, let's observe the question. So according to question, we have to prove yn as this. So out of that, we got these two terms outside. Now we have to simplify the bracket and we have to get this solution. So in the bracket, we should get x minus 1 raised to n in the denominator and x plus 1 raised to n. So let's find it out. So guys, let's come here. So first of all, I'll write down the minus 1 raised to n minus 2 term and n minus 2 factorial as it is. Now, in bracket there are 4 terms. Out of that, we can take something common from these 2 terms. But before doing that, let's simplify it. So minus 1 raised to 1 is minus 1. So here this will become minus n plus 1. So here I'll say 1 minus n upon x minus 1 raised to n. Next, with that, I'll take this term because here the denominator is same. So I'll say plus 1 upon x minus 1 raised to n minus 1. Next, here minus 1 raised to 1 minus 1. So this is minus n into plus 1. So here I'll say 1 minus n upon x plus 1 raised to n. And here it is minus 1 upon x plus 1 raised to n minus 1. Now guys, I'll give the brackets over here. Now we'll simplify the terms which are there in the bracket. So from these 2 terms, we can take x minus 1 raised to n minus 1 common. So guys, there we'll get so here I'll say 1 upon x minus 1 raised to n minus 1 common. Now, why are we taking it common? The reason is out of these 2 terms, x minus 1 raised to n minus 1 is the smallest term. So after taking it common, from here we will get 1 minus n in the bracket upon, here we will get only x minus 1 raised to 1. So that multiplication of these 2 terms will be x minus 1 raised to n minus 1 plus 1. So 1 cancelled, x minus 1 raised to n. Next, from the second term we have taken it common, so only 1 will remain. Next, from these 2 terms, what we'll do is we'll take plus 1 upon x plus 1 raised to n minus 1 common. Now let's see what remains in the bracket. So from here we will get 1 minus n upon x plus 1, because multiplication of these 2 terms will be x plus 1 raised to n. Next, we have taken this term outside, so only minus 1 will remain. So now here we'll simplify the brackets again. So we'll get value of yn as minus 1 raised to n minus 2 factorial, and in the bracket guys, this first term as it is, which is 1 upon x minus 1 raised to n minus 1, in the bracket we'll do the LCM. So that will become 1 into x minus 1, that is x minus 1. So guys, here we'll get 1 minus n plus x minus 1 upon x minus 1. Here we'll get plus 1 upon x plus 1 raised to n minus 1, in bracket 1 minus n, and minus 1 into this is minus x minus 1 upon x plus 1. Now guys, here we can cancel 1 with 1 and here 1 with 1. Next, we'll get yn as minus 1 raised to n minus 2 into n minus 2 factorial. Let's see what we get in bracket. Now guys, from here we will get x minus n into 1, that is x minus n, upon, this is x minus 1 raised to n minus 1, this is x minus 1 raised to 1. Multiplication of these two will be x minus 1 raised to n, because we'll add the powers for common base. Next, here out of this two, minus n minus, I can take minus n outside, so that will become n plus x, and minus n outside, so we'll get minus of n plus x, upon multiplication of this two will be x plus 1 raised to n. And guys, now if you observe the question, then we can say that we got the solution. So we got the exact value. So here we have proved the result for the given question, and I'm sure that you understood how I got the nth derivative for the function which is given at y1. So guys, remember this trick, because in examination you might get that original function y at y2, and then you may have to find out the value of yn by using the same trick. So guys, don't forget to follow the channel of Ekeeda. Also share this channel with your friends, because they can also get benefited with such a good explanation, and they can also get good marks in engineering. So do follow and keep sharing this channel with your friends. Thank you very much.